Hi everyone, welcome to my channel Code with Ease by Varsha. So as you might have understood from the thumbnail, we are here for the DSA revision guide. But this is not just another video which will help you, which is going to tell you that how to revise DSA, how to make notes while revising DSA. This is not that video. Okay. So what are we here for today? Let's say you have a tech interview planned from a week or two from now. So we know the pain of sitting with your notes, your Excel sheets, and so many LeetCode questions, and it is scattered everywhere. And you have to, all the things you have to consolidate and then sit for the revision. So we are here to streamline that process for you by ourselves helping you directly revise the DSA questions by doing this multi-part series. And that is what we are going to do today. Starting from today, that this multi-part series will consist of videos where we have handpicked certain DSA questions, mixed and match with different data structure, with different algorithms. And using that, it is like you just have to reserve maybe maximum 1 hour in a day to revise the questions and you'll be done. So it will be a very streamlined process because we will talk about the code, example, solution, the approach, the brute better optimal, time and space complexity. We have a detailed documentation of that. But what is this video for? If you already have a documentation, what is this video for? It is going to help you in two ways. Number one, the more you watch these videos as part of this series, it will help you gradually build a thought process because we are trying to make it more and more streamlined and make it more clear. Like we want to introduce more and more clarity because you have everything scattered. We know that you have done the questions. We know that you know the questions, but everything is scattered everywhere. Okay. Now to sit with all of that on your own to revise can be boring and frustrating. So we are here to help you with this process, which will help you build a clear thought process when you're solving the question. And the most important thing is to help you form patterns in your brain. And this is very important. Like you might have heard about coding patterns, coding interview patterns. Patterns in your brain is important because when you encounter a similar question before, later on in the interview, you'll be like, before I've done this question somewhere, so this is how we had done it. Now I just have to tweak the approach a little bit. So the videos, if you watch, this is going to help you in achieving these two things. And if you have these two things, revising DSA becomes a very smooth process. It is not at all difficult. So that is what we are trying to achieve with this, and we hope that we can achieve this objective of ours. The only assumption is that you have done the questions before, because we are not going to do a complete dry run of every question. We have already done dedicated questions and the videos in our other playlist. But this is a quick and clear and crisper revision as soon as you can do it. And that is why I'm saying, like, just reserve 1 hour in a day and try to revise the questions. That is it you need. So too much of talking. I don't want to waste any more time. Let's dive into it. That's it. Very simple code. So now with one question, we see how did we structure our thought process. See the question, the example, the brute force, the time and space complexity, brute better optimal, see the code, wrap it up. That's it. You're done with the revision. Moving on to the next question. I'm not going to take so much time for every question because this was the first question. That is why I just tried to elaborate. Starting with the first question called contains duplicate. So we are just warming up by doing some very simple, easy problems. And the best part is we are going to mix and match the questions. Okay. So this is the LeetCode question. Like many of you would have already done it, practiced it before. Given an integer array, you have to return true if the element appears twice in the array, at least twice, and you have to return false if every element is distinct. So you know that you have to return a Boolean value. You're given an array and you have to apply the logic accordingly. Now, what is the first thing? Like you go through the question, you understand the example. So when you sit for revision, you see the question, you see the examples, and then you start thinking in your mind, what could be the way to solve it? How should you ideally do is you see the question, run through the examples. Now, because this is very simple, it may take you 5 to 10 minutes hardly to try to think of the solution and maybe write the code. But I'm just telling you in a very general way, see the question, go through the example, pause the video, and think about it, what you can do to solve this question. Take 2 minutes, 5 minutes. Replay the video, okay? Resume the video. Now we will see what can be the approach. We'll start to form a thought process around this. So what we will do, see, I have tried to document it like this. First, we will see the brute force, if there is a better way, and then brute better optimal. So what is a brute force? the very first thought in a naive way would be maybe to have two arrays. Now, I'm sure many of you would have done much better solution than this, but just trying to give you an example of how things should be. Think of it like a complex problem, how it would be. Like your brute force way will be a very like a very naive way of doing the like the brute force will be the very naive way of trying to solve it. So in this case, we have O of n square. We try to make it little better by trying to sort the array. So when we try to sort, because all the duplicates will get lined up adjacent to each other, which will give us a time complexity of n log n. Okay. And the next thing is we will have hash set, which is the optimal way of storing, because set will only allow the unique elements, not allow the duplicates. So if I see the code for this code, if you see, what we are trying to do is we are trying to add to the set if the number is not there. So long the number is not there in the set, it will keep on adding 1, 2, 3, 4. But again, if 1 is uncounted, so at that time, it is not going to add. So what it will try to do is it is going to say that, hey, it's already existing. So it will be returning false. And then this condition will be true. And we are going to return true. That's it. Very simple code. So now with one question, we see how did we structure our thought process. See the question, the example, the brute force, the time and space complexity, brute, better, optimal. See the code, wrap it up. That's it. You're done with the revision. Moving on to the next question. The next question is product of array except self. So what we have to do in this, let's take a look. So we are given an array integer, we are given an integer array nums. You have to return an array answer such that the answer of I is equal to the product of all the elements of the integer, the array, except the number itself. Product of any prefix or suffix is guaranteed. Okay, so you must write an algorithm which has to run in O of n. Now when you see this, you will have to think of the solution in the optimal way. But still, even if you cannot think at first go, what is the optimal way of solving this? Let's try to think what can be the brute force way of solving this. Pause the video for a while and think about it. But yeah, also let's see the question. Accept the current number, in the new array, in the output that you have to give, you are given an input array and you have to also give an output array. So this output array at that particular index, the product will be equal to the entire product except the current number. Like over here, the entire product of this array is 24. Okay, so except this, so if I just exclude 1 from it, it is going to be 24. But for in case of 2, if I exclude 2, like 24 divided by 2, it will be 12. That is why it is like that. Now take a pause and think about what can be the brute force way of solving this. See, the brute force way can be to calculate the product of all the elements of each element. Product of all the other elements for each element, and then try to store that. But we also have to handle the case of 0. But the very first thought process will be again to have 2 loops. That is why the time complexity of O of n square. But if we can calculate the product of it at beforehand, okay, and also count the number of zeros, store the count of that and compute the total product. With the help of that, we can try to achieve it in one go, in one iteration. So let's see the code for that. So here we need to output this answer array. So we have initialized that. Initially, let's have the product as 1. And now we are trying to traverse through this array. We are checking whenever we encounter a 0, we will keep a track of all the zeros. So that is why we need this count variable. Otherwise, if it is not 0, then we are just going to multiply with our final product. Like we are just trying to get the product of the entire array. So that is what we have to do. So this for loop is just for calculating the total product of all the elements of the array and keeping track of the zero. So this much this part is doing. Next, we are again doing an iteration. This time, we are checking couple of things. So there can be 4 cases. So imagine this is the array. We have 1, 2, 3, we have 0 and we have 4. So if the count of 0 is 0, if the count of zeros is 1, there's only 1 0 in the array. The product at every position is always going to be 0. Because suppose you are over here, 2 into 3 is 6. 6 into 0 is 0. So anyway, at every position, at every non-zero position, your answer will be 0. But if you have only 1 0, but you have only 1 0 for for the index where you have a 0 present, for that particular index, the product is going to be the original product, because for this 0, the rest of the product is 6 into 4 is 24. So 24 is going to be over here. For everywhere else, it is going to be 0. This is very obvious to understand. So these two cases are covering that. You have only 1 0, there can be two things. Now, if there are more than 1 0, then very obvious the entire product, I mean, for every index, the answer of the output array is going to be 0. And what is the last option we have? That, okay, that you have no zeros in the array. It's a happy case. So you will just divide it like we were seeing that particular example. Let's say we do not have 0, 1, 2, 3, 4. At every place, it will be total product divided by the number at itself, like the number itself at that particular index. So that is what product divided by nums of I. That's it. And you just have to return the answer. So these four cases is what you have to remember. If there are 1 zeros, if there is 1 0, what will happen? If there are 2 zeros, what will happen? If there are 0 zeros. This is the only thing we have to remember. That's it. Next question is 3 sum closest. So let me open this particular question, and there is a variety which is similar, like 3 sum closest, 3 sum and the 2 sum. So these are similar questions. We'll try to see the code of all of them and try to compare. What is the question over here? You will be required either to find out the sum of the three integers or maybe required to print the triplets. So this is the triplet sum issue problem. So you are given an integer array and a target. Here you have to find such a sum of three numbers or three integers which is closest to the given target. In the 3 sum problem, it was like the sum should be equal to 0. Over here, it is like you have to find the sum which is closest to the target. And this is the example which is over here. You can take a pause and read the example. So what is the initial thought process? That we have to find out the triplets. Whenever you have to find out the triplets, the thought process is like you have to maybe use for loop to generate the triplets and check. That is the very initial brute force way of doing it. But we will be using 2 pointers to try to optimize the solution. So our optimal approach is going to be sorting and using 2 pointers. Even in case of the 3 sum problem, we will be able to do this. But let me first show the code of the 3 sum so that we can find that a little bit relatable. The 3 sums code, and over here, how are we applying the 2 pointer technique is, we are first sorting the array. So we are first sorting the array and then we are doing the traversal. We are skipping the duplicate because that was given in the question. Leave that. Come to the main point. The main point is we are using 2 pointers. We are using 2 pointers like this, having the for loop, and we are generating a sum. Like this is the sum which we are calculating as a reference point. Whether this sum, the first nums of I plus the left and right. Where is the left and right? They are at the extreme ends of the array. Now, if these three generate a sum equal to 0, we have found one triplet. Okay. Otherwise, we will have to continue generating. Otherwise, we have to shift the pointers, and that is what is being done over here. Everything else is just to handle the duplicate. So the main gist of this question is you will apply, first of all, you'll sort the arrays so that you can apply the 2 pointers. And then you try to find if the sum is equal to 0. If it is equal to 0, you'll add it to your output list. But if it is not, you will try to shift the pointers. So this is the 3 sum problem above. I have shown this because with the help of this is going to be the foundation to now see and understand the code for 3 sum closest. So now if we go to this question, so what is the code for 3 sum closest? It will be very much similar. The only difference is now we will not be. So the only difference is here also we are sorting it. Here we will try to check which is closer. So we have a reference point of the closest sum. The first 3 numbers will take as the closest sum. And then we continue generating the sum with the nums of I, the left and the right. And we check whether sum minus target is closer or closest sum minus target is closer. Whichever is the closer, that becomes our new closest sum. That is why closest sum is our reference point always. And incrementing and decrementing the pointers of left and right remains the same. So the structure of the code is the same for 3 sum and 3 sum closest. The only difference is here we are not comparing with 0. We are checking whether the given target and the given sum, which is closer, whether my sum minus target is closer or the previous closest sum that I have captured, if that is closer. That is the gist of the question. That's all you need to know. What is the time complexity for this? Are we using an extra space? No, we are not using an extra space. But we are sorting the array. So we know that when we sort the array, it is n log n. So the time complexity for this is going to be n log n. Question is longest consecutive sequence. So this is a LeetCode medium question. Like I said, I'm going to mix and match, shuffle the questions so that it's not like we are doing easy questions only or we are doing medium questions only. So I'm just trying to mix it up. Okay, so we are given an unsorted array integer nums. Return the length of the longest consecutive element sequence. What does, okay, and you have to run it in O of n times. So what does it mean? Let's see the example. The longest consecutive sequence you have to return. What is the sequence? The sequence over here, consecutive sequence is 4 because it starts from 1, 2, 3, 4. So the longest sequence, the length of that sequence is 4. So you have to return the length of that sequence. And over here, if I start from 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 2 zeros. So it should be like 2, like 0, 0. So that is why, okay, that's why the output is 9. So this is what you have to do over here. You have to start from one particular number and make sure that there is a next. It's like iterator.has next kind of a thing. And if it has the next number, that number plus 1 exists in the array, then you'll just have to do it. Think about it. Take a pause. Think about it, how you can solve it, and then we'll discuss further. So here's the brute force way of solving. Since I want to since I want to have the numbers in consecutive adjacent order, I can sort the array. I can have a max counter and just iterate through like 0, 0, 1, 2, just increment the counter as it goes. Now, I will increment it only if the current element is 1 more than the previous, like the num plus 1. And I can update the maximum counter value, which can store the length of my current sequence. And if it is a different number, I will break that sequence. What is the time complexity? O of n log n. So this is the brute force way of thinking it. This could be the brute force way of thinking it. Another way could be using a hash set, which will be taking up more space, but at least is going to give you a time complexity of O of n. So how are we going to do this? Let's see the code for that directly. Okay. So we will use a hash set and we need to keep a track of the length. So we'll have a max length. We will use a set. Set will not allow duplicates. All the unique numbers are added to the set first. Once we add the numbers to the set, we again iterate through every number of the set. Now try to pay attention over here. This is important. Okay. So we need to understand this. We are checking if the number is already contained in the set. If it is, see, I've written check if it is already in the set. If it is, skip the number. What does it mean? So pay attention over here very carefully. If there is a number, okay, given a number at a num set, if you have a number, if you already have a previous number of that, so num minus 1 is already contained in the set. So you encounter 2 and you see that in your set you already have 1. So I'm going to skip 2 because I have to start the sequence from 1 only. So I'm going to skip that. So that is why I'm doing this not contains. If it doesn't contain only, then I'm going to start from here. Otherwise, I'm not going to start from here. I'm going to start from the previous number. Now, if I come across 1 and I see in the set that there is a 0, I'm going to discard 1. But if there is no 0 in the set, then I'm going to start that my starting point is this. And that is what we are doing over here. If it doesn't contain only, then I will say my current num, my num becomes my current num and my length is 1. So now I am going to start my sequence and I iterate through the consecutive numbers, checking if my current num, like which my num became my current num, if that plus 1, if the next adjacent element is contained in the set. If it is contained in the set, because lookup in the set is O of 1. If it is contained, I'm going to increment my number, I'm going to increment my length. Two things I have to do. I have to increment the length. Very obviously, I need the length of the sequence. I have to increment the number because I have to check for the next number. So if 1 is there, I see that 1 plus 1, 2 is there in my set. Great. I have to do now 2 plus 1. I have to check if 3 is also there in my set. Then I have to check if 3 plus 1 is 4 is also there in my set, and so on. So while, that is why I've put this inside a while condition. You will keep on checking plus 1, plus 1, plus 1. You will keep on doing on the numbers and you'll keep on incrementing your length. Okay. And when you come out of this, means you have exhausted your particular chain or sequence of number is exhausted. Now you've got some other number, so you will update your max length. So this is how you may find short chains of sequence, and whichever is the largest chain or sequence, that length you will be storing in your max length. That is it. That is the question all about. Keep a hash set to keep track of the numbers. Iterate through the hash set, because look up in the hash set. See, all the numbers are jumbled up over here, right? So all the numbers are jumbled up. How can we achieve constant time? We have to use a set. That is why. Why are we using a set? Because I want to do a lookup every time. Plus 1, num plus 1, num plus 1 check. Or maybe I'm doing a num minus 1 check. Every time I have to do a lookup in the constant time, only then I'll be able to achieve the time complexity of O of n. That is the reason. That is the reason why I have to maintain a set. And because of that, I am able to achieve the O of 1. That is one thing. Secondly, because I am able to check that, I am also able to meet this condition inside a while loop, and I'm doing the incrementing operation. So it is like a win-win for me. I'm able to check also, and I'm also going to do my business logic and updating the max length. That's it. So this is how your code will be, and this is the optimal way of solving this particular question. The next question that we will do is longest common prefix. So let's check this question. Okay, this is an easy question. We have to write a function to find the longest common prefix amongst an array of strings. So you're given an array of string as the input. You have to find out the length. Sorry, you have to find out the string itself, which is basically you have to find out the prefix which is common to all the strings inside this array. So as we can see over here, straightforward, simple question, simple looking question. FLO is not okay. FLO is common between flower and flow, but not over here. So the only common string, prefix string is FL. So that is what you have to output over here. Over here, none of them is common. So this is the edge case. So you have to return empty string if there is no common prefix. That's it. Take a pause. See how can you use the string manipulation methods. Think about it and then play the video again. So here is the code for this. First of all, we check if, like a sanity check, if the length is 0, if it is null, we will return empty string. And we try to return this particular prefix. We first have a reference point over here. What is our reference point? The first element in that array, str of 0. That becomes our first prefix. Okay. Now, we start iterating over this. So this is my array over here. I start the iteration from I equal to 1. Now, what I have to check, this is an important condition which you have to remember. If you are not very well versed with string manipulation or string methods, pay attention. The element in the array, strs1, the ith element in the array, dot index of prefix. What does index of return? The first occurrence, the index of the first occurrence of this particular string, whatever you pass within. If the first occurrence of this is not equal to 0, what does it mean? Matlab, what does it mean? Like I said, the flower and we had flow. So if, let's say, flower is my prefix and I'm trying to check whether flow, which is my strs of I, dot index of. So is flower occurring somewhere in flow where it is giving me an index of 0, which means whether flower is contained in flow. First of all, it is not contained. So let's say now I'm not checking flower. I'm just checking flow.flow. Flow, I can see that this particular string is already contained. Or let's say I'm checking FL. I'm just checking FL. So I'm checking if flow.index of FL. Does FL start, is FL. So what we're trying to check is within the string flow, is the index of this particular string 0? Yes, because it starts with FL. But if it was like I'm not checking FL, if I'm checking for LO, what will be my index of? My index of will be 1, because LO is starting from index 1, not from 0. So I want to start the starting point, the prefix. So that is why I'm discarding it before only. If it is not equal to 0, what I have to do? I have to start chopping off. So over here, like I said, first we had flower, not a prefix. So I'm just going to remove the last character. I'm just chopping off the last character, and then I check if FLOW is a prefix. Not, again I'm chopping off the last. So this is what I'm doing inside the while loop. That is why I said that pay attention over here. First we're traversing, but as long as my current element, that is strs of I, is not giving me an index of 0, I'm going to chop off the last character from my given prefix. How am I doing it? I'm doing a substring 0 and the length minus 1, because this character will be exclusive. So this character is removed, and I'm only going to get the that much, like minus the last character, the rest of the string I'm going to do. But while doing this, if it happens that I have exhausted my entire prefix, all the characters are gone, it means that if the first two elements did not have anything common, if these two elements didn't have anything common, how will it have any common prefix with third or fourth? If you see this particular question, FLOW, flower and flow have something in common. At least FLO, these three characters are at least common. So that is why we proceeded with the next. But if there was like dog and race car, nothing is common, it will stop over there only. The prefix is going to be empty. That's it. That is what the question is about. Very simple looking code. It's a very LeetCode easy question. But you have to understand the playing of the string manipulation, and you have to remember it also, that what are we doing and why we are doing. Why are we using the index of, and why we are using the substring. Substring to chop it off, index of to find the index. That's it. So my new prefix is going to be this. Next question is largest number. So, what does this question talk about? Given a list of non-negative integers, arrange them such that they form the largest number and return it. Now, the number result may be very large, so you need to return a string instead of an integer. Okay. You are given an array of integer. Now, from this integer array, you have to return a string. What, by how you are going to return a string? By rearranging the numbers in this integer array such that they form the largest number. That is what you have been asked to do. Input is an array, output is a string. See this question, 10 is there, 2 is there. But if you just do integer comparison, it won't work. You have to arrange it in such a way that it forms the largest number. Okay. So now when you try to concatenate such a large number, it is not going to fit into your integer data structure. So that is why we are going to return it as a string. So 10 and 2. If I just group this, I can get 102 or I can get 210. Which is larger? 210. So I have grouped it and found that this is my answer, 210. Now it becomes trickier when you have more than 2 or like 3, 4, 5 numbers in the array. So there can be a lot of permutations that you can do. So in that case, it becomes tricky to write the code for this. So it is simply not just going to be concatenating A plus B and B plus A. So we have to think of it in a different way. Pause the video, try to think about the solution. Yeah, so the brute force way could be, like I mentioned, permutations. You have to generate all different permutation by looping through it. Now, when you generate permutations, as we know, it is going to be like a recursive call and going to be exponential time complexity, all of that stuff. So that is why it is better to avoid it. Best, we'll try to use the concept of comparators in string, and let's see how we can use it. Okay, there is one catch in this question. Remember that if at all by doing the concatenation, we find that the first number is coming to be 0, we will have to return 0. Like it cannot be like something like, let's say, after rearranging, you got something like 0, 2, 3, 4, 5. So 0, 2, 3, 4, 5. It cannot be something like this. So we have to just discard that kind of a number. So that is a special case we have to handle when we have zeros as one of the element in the integer array. So anyway, let's see the code for this. It will be more clear. And let's understand now step by step how we are trying to form the answer for this. So what is the input for me? The input for me is an array. Now if I have to return a string, I have to convert these integers into strings. So what is the first thing I have to do is I have to create a string array. I have to do is I have to create a string array so that in my string array, I'm going to do a string dot value, convert my integers into string and store it. That is the first thing. Step number one is this. Step one is this, to convert the integer to string. Now I have to create a comparator, and this is what I was talking about. If you do not know about comparators, I have done a detailed video on comparator hands-on demo in my channel, so you can refer to that. So comparator will help me to define a strategy on how I should be able to sort these integers, not integers, the integer to string converted numbers. Okay. So what it is trying to do, this is the comparator. It will take in two values. Now it is going to use this compare to method where we are trying to put the large number, like the large concatenated value first, followed by the small concatenated value. So that is why we are doing str. We are like, we have A and B, right? We have A and B. Check if B and A and B. Do a comparison of these two. So if B and A dot compare to A and B, and if this is greater, okay, put this one first, followed by A and B. And when we are trying to sort our this array of string, we are going to use this comparator, which we have defined over here. Because if you just reverse this, if it was like str1 plus str2 dot compared to str2 dot str1, that would have been the normal way of approaching, where you will have the ascending order, like the smaller first followed by the larger. That would have been the normal comparison. But in this case, the catch is that we will use a comparator. The catch is that we are trying to put the larger string. So we are trying to do it in the descending order. Okay, so that is why we are using str2 plus str1 dot compared to str1 plus str2. So we have sorted this array using this comparator. Now we have to handle the leading zeros. If after doing this sorting, now my new string array has a zero, like a zero, something like this, then I have to return zero, because I cannot have any largest number which starts or precedes with a zero. Next, we have to concatenate the sorted string. So now we have a string where we have the largest number first, like 23, followed by, let's say, 14, and then 5. We have something like this. So then I have to concatenate. So I can use a string builder. I'm going to concat through the array, and I'm going to get 2, 3, 1, 4, 5. This is going to be the new string that I have to return. So we are using this sv.toString to return this output string. So what were the steps that we have done? First, we converted the integer array to string array. We used a comparator to sort our string array. Step number 2. And step number 3 was to handle the scenario of 0 starting, preceding 0, and 4th was to concatenate. So there was like 1, 2, 3, 4 steps. And this is how the main gist was to create this comparator. This comparator was the main important thing. So this is how we can solve this question of finding out the largest number. Our next question is longest substring without repeating characters. So let's see this question. What are we going to do over here is we are given a string s and we have to find the length. We have to find the length of the longest substring without repeating characters. So if we see this example, we have this string. Now there are multiple substrings possible. Which substring has the longest length, which also doesn't have any repeating characters, which means I have to find a substring which has the only unique characters, number one, and I have to make sure that the length of that substring is the longest. So what is that substring over here? As we can clearly see, it is A, B, and C, or it can be even C, A, and B. Okay, so these substrings have the longest length. So we don't have to return the substrings, we have to return the lengths. Okay, now take a pause, think about it. What can we use to solve this? How can we actually try to find out the length? So like I said, there can be multiple substrings possible. So the very first thought process would be I'll generate the substring. Check number one if it has unique characters. For that, I have to traverse to the substring, and then I have to mark the maximum length that I've captured so far. So when I do that, then only I'll be able to understand that if I have got the max length at the end of the traversal. So that again involves two loops. One loop, you have to just start at one point, and then you have to generate all the substrings inside that, in the inner loop, is going to generate the substring of and the inner loop is going to keep on generating substring. So basically, this is going to give you a O of n square time complexity. So this is where we will talk about sliding window algorithm. So talking about the optimal approach, we need sliding window so that we can optimize the time complexity and bring it down to O of n. What are we doing? We need a set. We need to have a set to keep a track of the unique elements and the 2 pointers. Now, what are we going to do is we will add to our set only if the current element is not present. So let's say I start with this example. I have A, I added to the set, B, I added to the set, C, I added to the set. This is my substring. And I've captured the max length is 3. I'm going to add to the set only when it is not contained. This is what this part is doing. And I'm incrementing my J pointer, the right pointer, and it is happening inside a while loop. Great. Now let's say I encounter another character B. So I was going so far, captured max. Now I encounter B. So J is over here. I is at 0. Now, because B is already contained in my set, what am I going to do? I'm going to remove from the set the character which is pointed by I. Now, why am I doing that? Because when I see that it is already contained in the set, I have to reach to that point where my character of J is no more present. Because in my set, B is already present. So now I'll start chopping off from the left the characters. Because it is in my current substring, it is B is already getting repeated. So from the left side, I have to start chopping off so that I get a current substring which doesn't have any repeating characters. So now see, I will remove A, I'll remove A and I'll increment I pointer. Now this is my current substring. Now see the fun over here. My current substring again has a repeating character. When I check over here, does the set contain the character of J? Yes, B is again contained in this substring, and that is what we are trying to prove, right? In my current substring, there shouldn't be any repeating character, there shouldn't be any duplicate. So what will I do? I'll again remove from the left hand side. So I'll try to remove this B also. Okay, now I increment it. Now my J is still over here. Now it is going to check. Okay, now B is not there in my current set. So now because B is not there, I can add B to my current set. So at every given point in time, notice we are also keeping track of the size of the set. And now when I added B, now my current size became 2. So you see that this is my current substring when I am over here. And my current substring's length is 2, which is C and B are 2 unique characters. So what are the unique character substring we got so far? First, we had got ABC, we tracked the length as max. Then we got BCB, where again we had duplicate characters. Then now when we have this particular substring C and B, this is my correct substring which has 2 unique characters. So I got C and B and I got ABC. And I kept a track of the max. So I captured that this particular length is greater. So just give you a small dry run of what we are doing and trying to achieve. Number 1, we are using a set. Number 2, we are adding to the set if it is already not contained, incrementing J pointer or the right pointer. Number 3, if already contained, start removing from the left until and unless your set doesn't contain this particular duplicate character. Until and unless your set doesn't contain this duplicate character, you are going to keep removing. That is why we are doing over here. We will check if it contains, no. If it not contains, add it. If it contains, remove from the ith pointer till you reach that particular point where you can form a substring where it doesn't have any repeating character. Hope I'm able to make the point clear. If not, I also have a very detailed video on this, and you can watch that video also as part of the sliding window playlist. So these are the only things that we are doing, and we are done with the code and we are returning max. Very obvious, very small and simple code. Okay, so the next question that we will be doing is peak index in a mountain array. So let's see what this question is about. Okay, so an array is a mountain if the following properties hold: that there should be at least 3 elements in the array, and there exists some I where the elements before I is like in an increasing order and the elements after I is in decreasing order. Okay. So given such a mountain array, you have to return an index such that this property is satisfied, and we have to run it in O of log n complexity. So whenever there's a binary search question, few hints are very important. 1, the array is sorted, partially sorted. Number 2, you have been asked to solve it in O of log n complexity. Okay, so these are some of the hints that you can pick up. So this is a clearly an example of the binary search algorithm. And if you see this example, 0 1 0, so it's like a peak, so it has to be like something like this. Not sure if you can see this. So it's basically like a peak, so it goes from here till here and then it comes down. So you have to find out what is that peak and return that particular index. So over here 0, then 1 and then 0. From here 0, 2 and then 1 and 0. So it's like 2 is the peak, but you don't have to return the element itself but just the index of it. Okay, now how essentially are we going to solve this question? So here's the code which is written, very small, simple, sweet code. Now binary search, if you have done, again the expectation is if you have come for revision, you have at least done a couple of binary search. We have these 2 pointers which we commonly call low and high. One it's at the end of the extreme ends, like start and the end of the array, and we calculate the mid while we're iterating over the low to high. Now see, either there are 2 parts, right? It's partially sorted. This is the increasing order, this is the decreasing order. So your elements, when you calculate the mid, either it can be in this place or it can be in this place. So that is what we are checking over here. If after calculating the mid, you get to the mid of the array, now you see whether that element and that element plus 1, like if this is the mid and these 2, are they in the increasing sequence? We at least need some hint. Are they in this sequence or in this? So if they are in this sequence, then where is my peak? If it is I am in this, my peak will obviously lie just ahead of me. So that is why I have to increment my left or the low pointer. So low will be mid plus 1. Otherwise, I will be in this part. But there is a catch. You may be exactly at the mid. So if you are exactly at the mid, the number which is mid plus 1 will be smaller than you and you will be greater. Then this condition gets violated, that mid is not lesser, it is greater than this. Now because this condition gets violated, it is possible that your current mid is the answer itself. I mean your current mid is the peak itself, because it can be just at this boundary, that your peak and the peak plus 1, or it can be somewhere later. Whatever it is, I'll capture the mid. I don't want to take risk. I'll capture the mid and I will just decrement my high, because I have gotten to the decreasing part. Now I just have to go leftward, because I do not know, because I know that the peak will not be ahead, it will be somewhere towards the left. So I will shift my or shrink my high pointer or the right pointer. You can call it low to high or left to right, whatever suits you. That is it. And finally you have to return the answer, because I have captured. Now the possibility is that either your mid was the answer or it was not the answer. If it was not the answer, your mid will again change to another answer and you will decrement the high. At some point you will break the loop and whatever answer you have captured is the correct answer. That's it. That is the question, that is the answer. So what are the things we did? We had low to high. Simply we calculated mid, and the only thought process was either you find out whether your array, whether your elements are in the increasing sequence or in the decreasing sequence, and take the action accordingly, which is justifiable based on the logic we gave.